Friction, it is one of the forces. For example, an experiment like this. We have a block placed on the incline. We tilt it. It's not moving. First of all, we have a name for everything. This is equilibrium. All forces cancel each other out. We say forces, equilibrium. That's something from the past. And that means the force of gravity, which has two components relative to this surface. One component of gravity is parallel to this. We'll do some math. Second is perpendicular. Perpendicular component cancels normal force, but parallel component doesn't make it move. Friction keeps it. So when nothing is moving, this friction has a name, static friction. That's not always the case. If I keep tilting at a certain point, it starts sliding down. But still, there's interaction. Sandpaper, paper. That means force of friction does not disappear, but it now is a different kind of friction. Friction that is acting on a moving object has a name, kinetic friction. Of course, there's a transition between static and kinetic. And of course, this also depends on condition between the surfaces. If it's not a sandpaper, it starts sliding before. We need to give some kind of equations, definitions, which we could use. This comes from experiments. So right now, see, it's sagging. No tension. We cannot push the rope. We can only pull. That's what tension is. It only acts away from an object. The force is not zero anymore, but nothing is moving. So I'm applying about 3 newtons. That means there's a frictional force that cancels those 3 newtons. That means that force of friction right now, static friction, has magnitude of 3. I'm increasing force, friction increases to cancel it out. Now it's 4, 5, 6, 7, 8, 9, 10, 11, 12. At 12.5, it starts moving. That means this surface cannot provide friction more than 12.5. 12.5 is the limit, maximum value for the static friction. After that, well, maybe not 12.5. Anyway, after that, it starts sliding. So now the force of friction is kinetic friction. And what it depends on. Of course, we need more accurate experiments. But if I have another box, I'm doubling the apparent weight. The apparent weight, we know, has the same magnitude as the normal force. How does it affect? The force we need to apply, well, it's also almost doubled. So this experiment tells us a natural way to introduce a new physical quantity, new physical variable, a coefficient of friction. This is an official definition of the coefficient of static friction. Because the force of static friction can have any value between 0 and maximum. To define the coefficient, we use the maximum value, and then if we measure the maximum value of static friction divided by the normal force, this number has a name, the coefficient of static friction. Of course, that coefficient, that number depends on condition. If I put some oil, that will change the maximum value of the force of static friction. Definition for a coefficient of kinetic friction, frictional force divided by normal force.